Welcome to the CDS Squid for the NVMe-oF-Gateway. Ori, do you want to kick things off?
Hello, everyone. I shared also in the chat the link to the pad. If anyone wants to add any comments, I'll try to summarize what we discussed. So first topic is the biggest one, is the, well, let me try to increase the font. Is the font size, let's do the font size. Is that good enough or should I increase it more?
It's quite small. But it's okay now.
Okay, so the first topic, I think that's the biggest one, is the gateway groups. For high availability, basically we want to allow accessing the same RBD volumes from different NVMe-oF gateways. So that's one issue, and we can use also the gateway groups actually for maybe also scalability. This way we can actually won't share the gateway, the volumes between the gateway, but then we'll have multiple gateways that serve volumes. In both cases, there's the question how we load balancing, how we load balance the load between the gateways. Basically, how do we decide which gateway is going to serve which volume? I think today we just basically assume the user is going to do it, but we probably need to think to automate it, or at least have some, maybe just do one robin or something simpler. Anyone has comments about the load balancing? Do we think we...
In my opinion, at least for the first GA, we should not automate it. I think maybe it's enough to allow the user through the gateway CLI to say, which volumes, which gateway is the preferred volumes, which gateway is the preferred path for certain volumes, and then you can, spread the volumes across the gateways to get initial load balancing, and then maybe we can, in the future make it automatic or something. But that's a small point.
Anyone else has any comments about the load balancing? I agree about not automating as the first phase, but I'm guessing for large scale deployment, we'll probably need to do some automation because user cannot do it all the time. As for load balancing, we already have the mechanism for other Ceph gateways. So we can probably use some of the code in Ceph ADM to run the load balancers, or that's another option. Basically put a load balancer before the gateways, but that's more complex setup.
I don't understand the value of adding a load balancer before the gateway, to be honest, but I'm not sure if we're going to get into details now, but...
Yeah, I guess the main problem is that the mechanisms you have in NVMe-oF, I was also thinking about this, right, are not that powerful in terms of, telling the client exactly what to do. In the end, the client can always do whatever he wants and put something like HA proxy in front of it for NVMe or over TCP, right? You have very fine-grained control of where you want the traffic to go, right? So I also agree with you. I would rather not, but some customers or some users might have that requirement that they want this fine control.
Hmm. Okay, but in any case, in my opinion, it shouldn't be a feature of Squid. But you know Ceph better than me. But
Yeah.
okay.
So the thing is, right, there's already Ingress service in Ceph ADM, which basically uses HA proxy for various services. And it's probably fairly straightforward to add another one, but obviously needs extensive testing. So I agree with you, probably not something we should do now, but maybe this can be used in the future. Yeah.
Mm-hmm.
Next topic is the multipath and ANA support. So Jonas, what do we have currently? Basically, what configuration can the user do?
So currently, all paths are always advertised as optimized, since there is an issue open to basically set the ANA path state, which should be fairly simple. Explained before that it's already supported by SPDK. It just needs to be implemented as an RPC in the daemon.
Yes, but currently we don't allow configuring anything, right? So in the OMAP file or whatever, we don't persist anything, right, in regards to ANA.
That is correct. Yes, as I said, all paths are always optimized in the current code.
Okay. Okay. So it looks to us like we certainly need. I mean, our idea that we discussed here is that, for example, we can decide that for a certain namespace, that first the ANA will be an attribute of the namespace, kind of, and then you can say, okay, I have maximum 2 paths, 2 gateways to access a single gateway. We can limit it, maybe. That's our idea. And then somehow in the configuration, we should say, gateway 1, you are the preferred path to namespace 1. Gateway 2, you are the preferred path to namespace 2.
I mean, so this logic with like per gateway config already exists in the OMAP. So I think it should be fairly straightforward to implement it. Just take whatever else is already there, forward this past the SPDK. I think it should be a 20-line patch essentially to the daemon, maybe 30.
So in the OMAP, you can configure something per gateway today, because I didn't see. So gateway has an identification.
Yes. So okay, how it works is, so for the listener, for instance, right, they are per gateway, the listener IP imports, and this is already something that we have a pattern for how we put this in the OMAP. So that's already something we do today per OMAP, per gateway configuration within a gateway group, right? So I think the same pattern can be used for the ANA configuration. Since in the end, right, the ANA configuration is a property of the listener in that sense, right?
Mm-hmm. Okay, we didn't see it in the OMAP that there is something per gateway, but yeah.
I mean, it's not that there's a section just per gateway. It's that, for instance, for the listener, we have a specific way to store them per gateway. You should check out the listener setting code. It has this setup, but it uses the gateway name that you set, or that's automatically taken by the host name. There are these two options. And then it creates only on that node, it creates that particular listener. So that kind of code already exists.
Okay. Okay, but do you agree that it will be enough to say that we have up to 2 gateways? I mean, we can decide how many gateways we have in a group we didn't decide yet, but assuming we have more than 2, I think that it should be enough if we say that only 2 gateways can be used to access a certain namespace. It gives enough redundancy, I think. Do you agree to that?
I think, I don't think we should limit it in any ways. I think that the RPC should be in a way that the user can configure anything he wants, right? And of course, we can add some sugar on top of it, where we say you can let the daemon decide which gateways to pick or something like that. But generally, I think the RPC should be in a way that you can say this particular gateway has this ANA state, or this particular gateway has that one, right? I think we should allow this freedom generally, right? And maybe either someone puts something on top, or we have a shorter RPC call where you don't specify all the things and then it does something automatically. But I think in general we don't want to limit in what you can configure. And then it's not about the question if 2 is enough or not. It's then in the end up to the user how many he thinks is enough for him, right?
Yeah, and do we want to take care of saying at each point in time only one of them is the preferred, or we are flexible to whatever the user decides here as well?
Right. I think we should, in the end, support both. In the beginning, we could say for the first release, we only support one being optimized, just in terms of testing. That probably makes it easier. But I would say I don't see a reason why we should also not support all of them being active at the same time. Comes with some caveats, which we discussed in the past, but I think it should be possible.
Yeah, it makes sense. Let's start with one. Optimize. Multiple optimize has very complex testing. But we can consider if it's needed and if it's possible, and think about all the corner cases. So the second item is related, how many gateway in the group? So I agree with Jonas, we should be flexible, but again, we want to make, basically to simplify, it's complex enough, Ajay. So I would start with 2, one optimized, one non-optimized, and in the future extend it. But I think 2 is enough, and it's usually easier to test, manage, implement.
I don't think I don't think 2 will be enough. I think we should have 3 as a minimum for a typical setup. And then, it's fine if we say, for Squid, we only tested with 3, right, maximum. And in the future, we will basically test with more. But if you do more than 3, it's basically untested territory, right? That would be my opinion. But at least from the use cases, I know from the use cases we have internally, I think 2 is not enough. They will not consider this enough redundancy.
Sounds reasonable to me.
Yeah, one, I disagree. I think 2 is enough. Basically, this is the stateless gateway. It's very easy to spin a new gateway, configuring, and it can be optimized, even if you lose one, or non-optimized is even easier. The question is what I see lots of races when we actually, by mistake, and actually there's a different item about failed gRPC codes, put 2 paths that are optimized instead of 1, or maybe no optimized. 2 is very simple. 1 will be always optimized, the other non-optimized, and it's very easy to test and see. I would start with 2, and then after it's working, exceed it to 3 and the rest. I think the problems with 3 is almost the same as with 4.
Wait, before we continue to the next question, so we think that there is a problem right now with the failover and failback if we are not doing IP failover between the gateways. So I don't know, Jonas, what you tested, but what we saw in Flash system is that okay, so the initiator, at least the Linux initiator, will try to continue working with the IO controller so long that the IP is available. If the IP disappears, it will not try after some very short time. It will never try to reconnect to this IP. And therefore, if you're doing IP failover, then the initiator considers this IP to be alive, even if it's not doing IPs because it's not the preferred path anymore. But it will continue to consider this IP as alive. And then when there is a failback, the initiator will resend the IOs to this IP. But if you are not doing IP failover, then failback will just not work. This IP will disappear until the user manually doing NVMe connect. So the question is if we must do IP failover to support redundancy.
So I think we need to test it because the specs actually says that the initiator should try to reconnect to the optimize all the time. And basically, if the optimize patch is not available, it can use another optimize, but they should detect that the optimize is back and actually switch back. But maybe I haven't looked at the Linux initiator for a while, so maybe that's the way they implemented. In that case, we can actually go back to the load balancers and yeah, we can do the IP failover. Basically, we have the mechanism with Ceph IDM. We do it for NFS.
I think
but that's I'm not sure we can do it for Quincy. It's quite complex.
Yes,
I saw Adam here.
I think if this is really an issue, that maybe a better approach is to let the discovery handle this, meaning remove the path and add the path again. That should trigger Linux to reconnect to it.
Who will remove the path?
Right. So that would be something that would need to be handled by something like Keep Alive D or something like that. If this is really an issue, we have to check. So I don't know if you're familiar. There's a test suite for testing multipathing for the Linux initiator, which tests all sorts of different multipath settings. I run parts of it, not all of it, just to test if it works. So it might be a good starting point to run that.
Okay, I mean, our
can you
testing.
add sorry. Jonas, can you add a link to the testings for the listening?
Yeah, let me try to find it.
Okay, our experience with Linux initiator well 9 and /15 shows that it's not. I mean, I don't know what the spec is saying, but the initiators will not try to reconnect to an IP that was lost.
Basically, they should. That's the INA.
Aviv?
Yes.
I think indeed it depends on the return code you return. There is a bit which telling whether or not to try again. But if you don't set this bit, it will keep retrying.
Okay, we can play with it.
I know because I remember when I was working on the port set, I saw it all the time.
Okay.
Yeah, you can ask Eyal about it. I remember that we had a ticket to work on this a bit. I don't remember the details, but Eyal will probably remember.
Okay.
So this is very important because otherwise our day won't be working. So you need, I think the bit set will be the best. If not, we can look at the discovery, or if not, then if nothing works, we'll have to do the IP failover.
And the IP failover will not be the load balancer, right? This is different things.
No, that's the keep alive integration with Ceph ADM. Keep alive D. We have keep alive D for the NFS, but I'm not sure. Basically, the gateway can run in a different node and get the same IP. Maybe the similar mechanism need. Well, NFS is very IP driven, and you have to keep the same IP.
Mm-hmm. Mm-hmm.
But I would prefer not to do it. I don't like IP failover. Lots of issues, always.
Absolutely.
And I think, yeah. So about the allowing writes to non-optimized path, I think we have to. I think the spec says you can, and we actually don't know why. Well, it could be there's a network issue, and that's why we get the right to the non-optimized. The topology can be quite complex. So basically, I don't think I think we have to allow rights to the non-optimized path, even if the spec says you should prefer the optimized, but prefer not all.
Certainly.
And about data corruption, we talked about it 2 weeks ago. So between different hosts, that's block storage, they need to use mechanism to avoid corruption because different clients, different hosts. On the same NVMe-oF clients, the client will only use one path. So again, either you can use always non-optimized for some reason, but it will be fine. You won't corrupt its own data. So I think we are safe there.
Can you elaborate on this? Like who is well, first of all, what is meant by the same area? Who like how is that tracked? Is the area, is it a block? Is it a bunch of blocks? How it is defined?
The initiator will not write will not do data corruption if it's a single initiator, even if it has several path options to the volume. It is the responsibility of the initiator to make sure that it's not doing any data corruption, right? It's basic assumption, I think, in storage, in block storage. If you have several initiators sharing the same block device, then this is a different issue. They need to interlock somehow between themselves, how they coordinate the access to the volume. But if it's a single initiator, I mean, they are responsible to make sure they are not doing any overlapping writes. To the best of my knowledge, this is not something that we should be concerned about.
Well, but what if that single initiator uses multiple paths, and the path, the path basically dies? How is it ensured that the queues at all levels are cleared before the I/O is resubmitted on another path?
Right. So I'm not sure. I mean, first of all, I'm not sure how exactly the initiator is implemented, but I think it would be that the last write that was successful will be the data that you're going to get there. I mean, we can find out more about it, but to the best of my knowledge, this is not an issue that should concern the target.
Well, the reason I'm asking is that we are not, like the Ceph NVMe-Gateway is not a simple target, if that makes sense. Between the gateway and the actual storage, there is yet another, there is another network hop, and I would be very interested in kind of seeing a step-by-step breakdown of what you expect both the initiator and the SPDK instance in the gateway to do when the initiator has two paths available, like to the gateway, and then the gateway is there is a temporary network disruption between the gateway and the Ceph cluster. That, at least with iSCSI in the past, this scenario has been really just a huge can of worms, because you don't know what IOs are outstanding between the gateway and the OSDs of the Ceph cluster. There's no good way to cancel them, and you end up relying on matching timeouts to make sure that things properly time out before the initiator has a chance to resubmit the IO that it believes to be stuck on another path. So I was just we don't need to go into that level of detail here, because there are other topics, but I just want to, because the wording here made it sound to me like we were dismissing this issue, and I really don't think it should be dismissed. It should be investigated in the all the way down to like a single individual, like sector-side IO getting stuck at any point on the path from the initiator to the OSD, and make sure that each of those cases is handled correctly, and not just with Linux initiator, but with any initiators that we plan to test with.
Mm-hmm.
I agree. We need to.
Yeah. Okay.
Yeah, we need to make sure. I agree, it's another hop, but you need, so, but most, basically NAs for NVMe-oF, and most targets are complex. But yeah, basically the area is, I think, it's sector. I agree, but it's also up to the initiator. For example, in flight ops, that it then didn't get acknowledged from the target, and a switch, you will need to resubmit them. That usually is the use case.
Yes, but that's exactly the problem. If the initiator resubmit, like the initiator needs to be prevented from resubmitting these IOs before it is safe to do so. That's the crux of the issue.
Yeah, we need to see that it's fine with that. I agree. There are corner cases. Actually, I would say, yeah, it's a different client. It goes to ADOS and so on. Yes.
Yeah, I'm not sure I understand why it's different than running two librd clients and running IOs to the same volume. But I mean, we can take it offline. But I understand there is another hop, but the results should be the same. The last one that was successful writing the IO will probably be the right one. But yeah.
Right, but if the initiator resubmits the write, or like it's it's always more than one write, right? It's there's going to be overlapping writes, and so the initiator would resubmit one of those writes. It gets committed. Then it doesn't even need to be overlapping. Just a future write would overwrite part of that block, for example, and then on the original path, like the temporary network disruption between the gateway and the Ceph cluster, resolves itself, and the old write with the old data would overwrite that block yet again, and and you're not going to like the semantics that you're getting, that's equivalent to data corruption, because you've essentially lost part of the write that was applied in good faith and wasn't doing overlapping necessarily, right? It could have come, seconds later, but if the timeouts aren't matched, like I said, if the initiator is allowed to resubmit the write before it has been either timed out or flushed, in all the queues, like all the way, that's that's a recipe for data corruption, and that's why I'm saying that this issue needs to get the kind of the utmost attention.
Yeah. Okay.
I would guess the timeout for the old request and the resubmission actually detect switching to the non-optimized is larger than actually the time the request can time out. But we need to check to confirm that's always true.
Yeah.
Any more issues, comments on gateway groups?
So last comment. So I wanted to say to ask if on the gateways that are, assuming we have assuming the user didn't define that he wants to access a certain RBD from a certain gateway, do we somehow need to report this as not available through the ANA in this gateway? Something that I'm not sure about. Okay, let's leave it for now. I'm not 100% sure about it yet. So we can continue. Sorry, I wait.
I think the spec allows us to decide. We don't have to smoke namespaces is not accessible, but then basically you need to get an error when you try. It helps. I think it helps the user when we do set it. It's not accessible, but that's a future discussion.
Yeah. Yeah.
I think you could just set the path, just pick the optimized path based on which gateway ended up serving the request to create that namespace, because that would likely be load balanced, and whichever gateway ends up committing that information, ends up creating that gateway and updating the OMAP, the configuration in OMAP, can just be, it can just select itself as optimized, and the other would automatically become non-optimized. That I think is a very simple way to handle this. If we wanted to do that, instead of marking as like not available or whatever.
Yeah, but if we go with only 2 paths in the first release for namespace, then you need to pick another one that will be the non-preferred, and the others should report not inaccessible or something, right?
Yes, but I'm saying that would I think the way I see it, that would happen automatically, because there's going to be, again, like Jonas mentioned, there was a way to store kind of pure gateway pieces of metadata, and if we commit a piece of metadata that says that gateway A should be treated as an optimized path, then other gateways can just declare themselves as not optimized. And all of that would happen based on that single update to the configuration in OMAP. There is no further logic necessary, unless I'm missing something.
Yes, but then, I mean, yeah, if we said at the beginning that we want to allow maximum 2 paths, I mean, one failover, 2 paths per namespace. So assuming you have more than 2 gateways in the group, you don't want to allow accessing this namespace from another gateway, right? You want
Well, I've understood that discussion as we would not actually limit anything, and those statements would be just they would be of the form that we've tested this configuration, like we've tested like, let's say, 3 gateways in a group with only 2 kind of participating for each particular namespace. That would all be support statements as opposed to limits in code, and so like, and therefore that does not necessarily need to be enforced if the user wants to have more than have 3 gateways, and then have only individual pairs of gateways be handling a particular namespace. Then I would argue that that's actually a more complex configuration, because yes, in that case, some logic would be needed. But that's I think much more likely the users who want 3 gateways in a group would probably not want to limit namespace to just 2 gateways, and the users with the default, which we would recommend, which is 2 gateways at least initially, like no further changes needed, because there are only 2 gateways, and the unavailable path, like there is nowhere for it to come from.
Okay. Wait, I have one more question. When there is a failover, do we want to report the non-preferred path as preferred, or do we just assume that the initiator will see that it lost the preferred path and will go to the non-preferred path? If we do want to change the path from non-preferred to preferred, then we should, I don't know, get some event or something. The gateways are not familiar with each other, right? So they don't really know if the friend gateway is lost. So, but if we don't do it, then from what I understand, the failover will take more time, because the initiator gives some charity, some grace to the optimized path until it decides to go to the non-optimized path.
Well, I think that's the way I see it, because the gateway, it's not up to the gateway to determine when there is an event, or when there is a condition that would lead to failover. That's not up to the gateway. unless there is kind of a major disaster with the like the gateway just can't talk to the Ceph cluster at all, and it detects that, but that's also likely to be based on some kind of timeout. So like the gateway just wouldn't know that there is an issue. So I think these all of these directions would come from the initiator side, and therefore there is probably nothing to update as far as path states, unless there is something in the spec that requires the target to update its state once it sees certain behavior from initiator. That I'm not sure about.
There is nothing in the spec from what I know, but from what I think, and I think we saw it, is that the failover will take more time because the initiator gives some grace to the preferred path until he decides to go to the other path. So it might be a very small time frame. We should check it. But in case you send an event, an async event from the target to the initiator saying, path changed, now this is the preferred path, then it will certainly the failover will be faster. This is easier to do if we implement IP failover, which we don't want, but yeah, that's the trade-off actually. So,
Well, I'm with Ilya. I think gateways don't have the information on the cluster, and they shouldn't do that because they're failover because it's quite complex. We probably will need to handle things like the gateway, the optimized gateway when is out of the cluster. Maybe we need to find a new optimized or something like that. But actually doing the failover, I wouldn't try it. I think it cause lots of corner cases. We need to handle like 2 gateways, things to optimize and stuff like that.
Yeah, but
I agree.
The other, yeah, go ahead.
Yeah, as for the extra latency, so if it's a part of the NVMe Connect, that's fine, nobody will notice. And for I/O, I think most of the gateway either will feel it because they are doing I/O to the optimized path, and basically we need to switch in any case during the I/O. And those that were idle during that time and do the first I/O would have the less latency cost, but then they're gonna switch to the non-optimized. If it won't be good enough, we can consider seeing what to do. But again, it won't be by the gateway. It should be something more, let's say maybe Ceph ADM or something that we need to think. Maybe actually the monitors. I don't know. I need to think who's gonna decide when actually a gateway is not coming back, and I need to do failover. It's quite complex logic. Yes, go ahead, Ilya.
I just wanted to add that there is no, like in any given gateway, at least assuming based on previous discussion in this meeting, any given gateway would have a set of optimized paths and a set of non-optimized paths for the different namespaces, right? Since we're not like we are going with the more complex model of this being a per namespace thing as opposed to a per gateway thing, and therefore, like when even if the gateway is declared to be or perhaps it learns that it can no longer talk to the cluster, or something declares it as dead, that is it concerns only a subset of namespaces on the gateway, only those for which it was reporting as optimized.
Maybe just one thing I want to add is, so we're doing it per subsystem, right? Like since we are setting the ANA state per listener. So it's always a group of namespaces that we fit. And one other comment I want to make is that, from an initiator point of view, you can have a health checker and everything in your cluster that kind of sends asynchronous or tries to reconfigure from another pass from non-optimized to an optimized if one fails. But from initiator point of view, it could also be that the pass failed for other reasons, and the health checker still reports the gateway is up and running, right? So the initiator always has to be able to switch over to a non-optimized path either way, right?
Mm-hmm. Yeah.
Right. That's basically why I was just saying at the beginning that this, in my opinion, should be initiator driven and trying, having some kind of a synchronous event to potentially speed up the failover in the case when it is somehow detected on the gateways and is kind of coming from the gateways. That is definitely, just in my opinion, that just the performance enhancement that can be deferred almost indefinitely, really, because that's just not something that that matters that much.
Okay.
So the next topic is the concurrent gRPC, but I'm not sure we have time. We have 9 minutes. So do we want to defer it for next week upstream meeting, or?
Yeah, I think it's a deeply technical topic. There is no point in discussing it here, and it's probably going to need like an entire meeting allocated to it.
Yeah. And discovery service. Do we have? I'm not sure. Do we have anyone from Intel working on the discovery service? I assume no. So let's move it also to the upstream meeting. Multiple pools we discussed last meeting. I attended the upstream one. And another question is, how many cores are assigned to SPDK for the I/O load? Which is a very good question, actually.
Yeah. So we added it. So yeah, right. Sorry.
Yeah, no, I mean, I can just quickly summarize at least what I have in my mind is that there's two things in SPDK, right? And they are now both configurable. So one thing is the reactor threads, which essentially handle mostly the NVMe-over-Fabric side, right? So they are taking basically the I/O, they're doing the NVMe-over-Fabric command processing and handing it off to librd. And that is the second part. So librd, of course, internally has a bunch of threads, like I think in the order of 5 per default or something like that, right? And what we've done is, so the number of reactor threads is configurable when you start SPDK, and you can actually put this in the local config file that we have for the daemon, right? And then the daemon makes sure that the SPDK is started only pinned on that particular course you told it to run on. So that's number one. And number two is we added a way that when you create a Ceph object in SPDK, or a Ceph context is what they call it in SPDK, which just means it's another librd client instance. So if you add that, you can specify also a core mask. So you can basically define where the librd thread should run, like should be pinned on. This is currently not enabled through, it's not configurable through the daemon. It just exists in SPDK. This would be something we need to push through, right? So these are the two things.
Okay, so first, I mean, I think we need to make sure that the reactor and the Ceph and how do you call it, Ceph context threads are running on the same cores, right? Or even on the same.
No. So I mean, okay, maybe you think the same thing, but okay. So what we had so hopefully they're not running exactly on the same cores, but probably yeah on the same node, on the same NUMA node. If they're running on the same core, we had these issues in the past that obviously they were stealing each other's cycles and we got really bad performance. That's, by the way, in the first place why we introduced a way to set this core mask to make sure that the reactor threads are running on different cores than the librd thread.
Okay.
Yeah, but NUMA awareness, obviously, you're absolutely right, is important. But again, here, I don't think we should be super intelligent. In the end, it's up to the user, right, to do a right job. I don't know if for Ceph, otherwise for the OSDs or so, you do any NUMA pinning automatically. At least from what I've seen, I don't think so. But yeah.
With Ceph, we don't do any, like you can do it, but it's completely configurable and it's usually not very effective. But I think for SPDK it can be. And also, if you collocate Ceph, like all these with the SPDK, I would want to make sure SPDK is not running on the Ceph core because SPDK is very CPU intensive.
Right. So I think initially we should just make sure that it's configurable, but not do something smart about it in the sense that let the user define it. But eventually in the future, we could also add something that kind of, I don't know, figures out by the network device on which NUMA node to put it on or something like that. But that's really complex, so I would leave it for future.
When you say make it configurable, how configurable? I mean, via the CLI or what?
Yeah. So, I mean, have a RPC, right? That you can define those both things, well, or in the config, right? So for SPDK, we have the option already that you can set how many reactor threads and where you want to run them. I think the only thing we would need to enable is where you want to run the librd threads. Again, that's already, we did a PR that's already merged in exactly. Thank you, Rahul, for putting it in. It's the JSON RPC is called RBD BDEF RBD register cluster, and that we added an option to that allows you to set the core mask. So, but that is not enabled through the gateway itself, so it needs to be enabled.
Yeah, I guess that's one of the gaps in CLI and gRPC, believe, to start with. Because even I see in the present implementation, right? So the gateway server logs keep on complaining about a warning telling that BDEV RBD create should be used with specifying -c to have a cluster name after BDEV RBD register cluster. So I guess we would need to have a CLI support for this RPC method.
I mean, not directly, right? In the sense that we will only always support one cluster per gateway. So it needs to be implicitly within the daemon code. We don't want to really expose it directly, meaning there should be a way to set this mask somewhere, but the user shouldn't be able to call something like register cluster, just to be clear.
Okay.
So we have 1 more minute. Maybe we can squeeze the last item. What is the ratio between incoming NVMe traffic ports and RBD outgoing? It's actually not something I have.
Right. So from what we saw is that we need, if we have a 100 gigabyte port, you need double outgoing ports to get to the performance that you can get from this port. So I'm not sure what's the policy in Ceph about it.
I have to say that I'm not sure what this means. So what do you mean RBD outgoing ports? Do you mean like on the gateway, the same amount of data would go through the network between the gateway and the cluster?
Yes.
Yeah. So I'm not sure where the double, like where the increase is coming from, because if you write if you write one block, if the initiator submits one block of data, then barring protocol overhead, which is negligible, that one block would then be output to the on the network between the gateway and the cluster. There is no, I'm not sure where the increase that you're seeing is coming from, but it's not inherent in the architecture.
Okay, so we can say one-to-one, but we are we leaving? I mean, for each incoming port, we say we have another port that will serve as the RBD traffic, or there is no, or we say
there's no concept of ports really. It's just the librd is going to open a bunch of sockets, and you don't have control over that. It's going to open basically a socket per OSD. So if by port you want to say like socket, then that's just naturally bounded by the number of OSDs in the cluster.
Mm-hmm.
Yeah, it's
And
more
again,
correction.
like,
go ahead.
sorry, you ahead, or no, I just wanted to say that in the end, again, it all depends on what the user wants to do, right? What we tested is 100 gig, 200 gig ports. One we used for the client side traffic, 100 gig to basically NVMe-oF, and 100 gig linked to the Ceph cluster. And we were able to show that if you can basically drive 100 gigabits through, from the front end to the back end. So that's possible. I mean, we shared these benchmarks in the past, but I can also send them to you again, Aviv.
Okay.
Yeah, so I think just to kind of summarize, there's definitely not 1-to-3 or 1-to-2 ratio, because replication in Ceph is it happens on the back end. So the bandwidth between the initiator and the gateway, and between the gateway and the Ceph cluster, those links or ports can be exactly the same, and there's no ballooning of any kind.
Okay, fair enough.
And we are out of time, so thank you, everyone. We can discuss the other stuff or just in the upstream meeting next week. Probably start with the gRPC concurrent first handling. So thank you, everyone, for attending.
Thank you. Thank you, everyone. Bye-bye.
Thanks.
Bye.